In this video, we're going to look at some applications of right triangle trig. Let's look at a few definitions first. So we're going to talk about angle of elevation and angle of depression. So when we talk about the angle of elevation, we're thinking about looking up at something. We're looking up at an airplane in the sky, or we're looking up at the top of a flagpole, or we're looking up at the top of some kind of monument like the Statue of Liberty or something. So when we talk about the horizontal, we're talking about if we were to look straight, that would be a horizontal. So we could draw this kind of triangle between our, if we were to look straight, and then the object that we're looking at. Maybe, like I said, it's an airplane in the sky or a hot air balloon or in the top of a monument. So we could drop a perpendicular from the object down to the horizontal, and we can build this right triangle. The angle of elevation is what we're looking when we're looking up at the object, and that's from the horizontal. When we're talking about angle of depression, now we're looking down at something. So maybe we're looking down at something that's on the floor, or we're standing on a cliff like the Grand Canyon, and we're looking down at a spot on the river. So the horizontal would be if we're looking forward. We could drop a perpendicular line to the object. So there's my triangle that I'm building. And then the angle of depression is from the horizontal, if I were looking straight ahead, down to the object. And you can see how in both cases we're building this right triangle. So we could use some right triangle trig to figure some things out. So let's look at a few examples. Number 49. We have this gorge, and the distance from point B to point C is 100 feet. And we've got an angle in between here. We're trying to find the distance from A to C. So how long is this gorge? Or how wide is the gorge? So not really angle of elevation in this one, but we could still use some right triangle trig to figure that out. So I don't know what this side is. I'm going to call it side B. I need to figure out what trig function ties everything together. So here's the angle that I have. I have the adjacent side. I'm looking for the opposite side. So the trig function that ties everything together here is the tangent. So we're going to say tangent of 35 degrees is equal to opposite, which I don't know, over the adjacent. And then we're just going to solve this for B. We're going to multiply both sides by 100. And then we can type this into Desmos. So I'll show you how to type this one in Desmos, and I'll start doing these off screen. So we have 100 arc 10 of 35. We want to make sure we're in degrees because it's 35 degrees. Oh my goodness, I'm not sure what I'm thinking there. Let me go back. It's 100 tangent of 35 degrees. We don't need arc 10 there. So 100 tangent of 35. And then we're going to get 70.02. So that is our approximate length across that gorge. Okay, let's look at another one. And this is where you may want to pause the video, try it, and then come back and check your answer. So we're looking at the Eiffel Tower. And we are trying to figure out the height of this tower here. So here's our right triangle. So we've got an angle here, kind of like an angle of elevation, if you will. And we're trying to figure out height. So I'm going to call this guy A because we don't know what it is. We need a trig function that ties everything together. So let's think about what we have. We have this angle. we have A is what we're looking for. This is the opposite side. And we have 80, which is the adjacent side. So once again, we're going to use tangent. So we're going to have tangent of 85.361 degrees. And that's going to be equal to opposite, which we don't know. That's what we're looking for, over adjacent. Multiply both sides by 80. And then I'm going to do this one in my calculator. But we could do it in Desmos too. Make sure you use tangent on this. And we're going to get about 985.9 feet. Okay, let's look at another one. You may want to pause the video, try this one, then come back and check it. Security camera in the neighborhood bank is mounted on a wall 9 feet above the floor. What angle of depression should be used if the camera is to be directed to a spot 6 feet above the floor and 12 feet from the wall? So let's draw a picture of what's going on. So here's my floor. Here's my wall. We have a camera that's mounted here, and this is 9 feet above the floor. So this line down here is the floor. What angle of depression should be used if the camera is to be directed to a spot 6 feet above the floor and 12 feet from the wall? So we want to be 12 feet from the wall and 6 feet from the floor. So I'm looking at let's think about what's going on here. So here's theta. I don't know what this is. This is what I actually need. Because we want that camera to be directed down here this way. Now, if this is 6 feet and this is 9 feet, then this guy is a total of 3 feet. So I need to figure out what this angle is. And if I know this angle, then I'll know this angle by default because I know they have to add to 90 degrees. So let's find theta. And the trig function that's tying everything together, again, is the tangent. So tangent of theta is equal to opposite over adjacent. And this time I'm going to use inverse tan. And 12 over 3 is 4. So if we're doing this in Desmos, this is where you would use arctan. I'm going to do this off screen on my calculator. So I get tangent to be 75.9638. So it's about 76 degrees, right? If I were to round to one decimal place. So if this guy is 76 degrees, then this guy is going to be 90 minus 76, which is 14 degrees. So we would need that angle of depression to be 14 degrees. Okay, let's do one more problem. Let's look at an angle of elevation. So we have the Washington Monument. The angle of elevation of the sun is 35.1 degrees at the instant that the shadow cast by the Washington Monument is 789 feet long. Uses information to calculate the height of the monument. So let's draw a picture of what we know. Here's our monument. We're looking for the height, so I'm going to call it X. This is 789 feet, so this is the shadow. And we're looking at the angle of elevation. Angle of elevation would be 35.1 degrees. So we're looking for that height here. Once again, we can use tangent. So tangent of 35.1 is equal to opposite over adjacent. So 789 tangent of 35.1 is going to be equal to our value we're looking for. And I got about 554.5 feet.